So we have learned the Pythagorean theorem. We have used it to find sides of triangles we don't know. We have used it to solve word problems. Now we're going to use it to find the distance between 2 points. So you notice here, they've got a point plotted right here and right here, and we're trying to find the distance between those 2 points. We're trying to find the length of this line segment, okay? Well, we don't know exactly how long it is because since it's a diagonal segment, we can't just count squares. Now, think a minute, look at this diagram. How do you think this might be related to the Pythagorean theorem? Can you think of a way we could use the Pythagorean theorem to find the length of this segment right here? What did you think of? Did you happen to think that if I draw this segment and this segment, I form a right triangle? If you use those grid lines there, see that right triangle? Did others of you think, well, what if I drew this segment and this segment? Would that work? Is this a right triangle? What would these together make? This is a rectangle, right? And so that segment is really the diagonal of a rectangle. And we have said that the diagonal of a rectangle is a hypotenuse of a right triangle. So it does not matter if you draw the right triangle above or the right triangle below, you can find the length of this segment. As long as you use grid lines, it's got to be a right angle, and you've got to use grid lines. This is just like our slope triangles. Remember when we did slope triangles and we connected them like this? That's the exact same thing you've got to draw, okay? So, since this is the hypotenuse, that means we're trying to find C. So we count and we say, well, that leg is 2 spaces long, and this leg is 1, 2, 3, 4, 5 spaces long. That's just like we did with slope, right? We can now find the slope of this segment, right? The slope of this segment, the rise is 2, the run is 5, we get 2 over 5. But we want the length of this segment. So we're going to use the Pythagorean theorem. We're going to plug in our legs, the length of our legs, I guess. We're going to get 4 plus 25 is c squared. That's 29. We're going to take the square root, and it says to round to the nearest tenth. And the square root of 29 is approximately, once we round it, 5.4. It's 5.38. If we're rounding to the nearest tenth, we'll round that up to 5.4. Okay? All right, so you try it. You try it with this triangle. I mean, not this triangle, this segment. They want the distance from here to here. I want you to draw in your right triangle, count the lengths of your sides, use Pythagorean theorem, and then check your work. I got that the distance from this point to this point is approximately 3.6. I drew the triangle down here. Remember, you could also draw it up here. It does not matter. Used Pythagorean theorem and got 3.6. Now, these next two are exactly the same. They just have not plotted the points for us. So we have to plot the point 4, 5. So we're going to go, our x-coordinate is 4. So we're going to go right 4. And then our y-coordinate is 5. So we're going to go up 5. And we get this point right here. And then the point 0, 2, the x-coordinate is 0, so we don't go anywhere left or right. We go up 2, so we're on the y-axis, and we're trying to find this distance right here, okay? So that's the hypotenuse of a right triangle. So which right triangle do we want to use? You can use this upper right triangle or the lower one. Does not matter. I'm trying to find C. This length is 3, that leg. This leg, 1, 2, 3, 4, is 4. So I'm going to do Pythagorean theorem. I get 3 squared plus 4 squared. this one's exact, and we get 5. We should be familiar with those numbers, right? 3, 4, and 5. We did those with our Cheez-Its, and we've seen those numbers come up before, okay? All right, so you do the next two. Plot these 2 points. You may, if you want to, turn on the video and make sure you've got your points plotted correctly. Then draw in the segment and find its length. Okay, there's your 2 points, -1, 1, left 1, up 1, -4, 4, left 4, up 4. So now you're trying to find this distance right here. So pause the video, draw in your right triangle, and find the distance between those 2 points. I got that the 2 sides were both, the legs were both 3. That would make this an isosceles right triangle, right? Because 2 sides are equal, that's isosceles, has the right angle. And then when I plugged those in, I got that the distance from this point to this point was approximately 4.2, okay? If you have any questions, let me know, and we're about to do some practice with it.